Shekhar, Associate Professor, Department of CSC, Kids, Warangal, Andhra Pradesh, India. Today, I would like to give a presentation on data structures and stacks, ADT, and applications of stack. This data to suit a specific purpose so that it can be accessed and worked with an appropriate way. So, depends on the application, we can create the data structures as per the requirement here. Normally, data structures are used to store it is a process of storing the data in such a way to retrieve the data. Data structures are classified into linear data structures and non-linear data structures. Let us, linear data structures are examples of stacks, queues, linked lists, etc. Non-linear data structures are trees, graphs, etc. Let us see today what is a stack. Stack. What is a stack? Stack, let us see. Stack is a linear collection of elements, in which we store the elements and we retrieve the elements at one end. That end is called the top. So let us see example. Stack works on a principle of last in, first out. A general example of stack, suppose we have one end open a box. In this box, suppose a cost, schedule costs. Suppose schedule costs are first inserted cost will be stored in the bottom of the stack. Second cost will be stored over that. Next, so on, the storing of the cost in a box. Similarly, I want to remove a cost from the box. So, which one will come out here? So, the last inserted cost will be coming out first. And let us see another example. Suppose organizing the elements, a plates on the disk. Plates on the disk here. This is the way organizing the elements on the disk here. Books. A pile of books or pile of plates, etc. Suppose another example, let us see to understand it clearly what is a stack here. This is one end open. Suppose item A I inserted into this stack and this is called top end. After some time, next I added one more element to this stack. Now top gets updated, gets incremented, and then after another one more element I inserted into this stack. Then after like this, stock gets incremented. The major operations of stack. Major operations of stack: push and pop. Push is nothing but adding an element into the stack is called pushing an element into the stack. Pop is an operation which means removing an element from the stack is called the pop operation. Whenever and coming to abstract data type. Abstract data type means abstract data type is a mathematical model for a certain class of data structures which have the similar behavior for certain data types, one or more programming languages that will have similar syntax. For example, stack is an abstract data type. Here, what operations are called abstract data type? Stack consisting of push operation, pop operation. These are the inserting some data into the stack structure and extracting, removing an element from the structure. So, these are the ADTs of a stack. The major operations of a stack, we need to check the four conditions, four operations. Number one, in the process of stack implementation, first we need to create the stack. Next, Second one, we need to check whether the stack is full or not. Third one, whether the stack is empty or not. And the fourth operation is push operation and another operation is pop operation. In the first one, create. So I want to store the elements into the stack. Then first I need to allocate some memory for storing of elements. So that is called creation of a stack. Next, after creation of, then suppose I am performing an operation, push operation. Before adding an element into the push operation, I need to check whether the stack size is, memory is available or not here. Whether the stack is full or not, I need to check out. So with this operation, stack is full, operation is to be checked. So in the push operation, one condition I must check here, that is whether the stack is overflow or whether the location is free or not, I need to check here. Then coming to the pop operation, whenever I want to remove an element from the stack, then here also I need to check another operation here. Suppose there are no elements in the stack, I cannot remove an element from the stack. So I need to here, I must check here, the stack is empty. Is empty operation must be checked here. So is empty, is full and is create, these are ADD operations, and push and pop operations must be checked. The implementations of, next topic I go to implementation of stack. So stack can be implemented in two ways. Number one, array based implementation, and another one, list based implementation. Array based implementation means pre-allocation, predefined memory allocation, that is called static memory allocation method, and list based implementation is method of dynamic memory allocation here. Whenever dynamic memory allocation means whenever I want to store an element into the stack, during the execution of my program, I will allocate the memory at runtime. So that is a process of list implementation method, and static implementation means using arrays, so predefined allocation. Allocate an array, predefine some size of elements, and at the bottom of the array you store 0, and let us take the array size is the index, array 0, 1, 2, 3, 4. The first elements will be stored in array of 0, and next element will be stored in array of 1 and array of 2, like this. Then whenever we delete an element or pop an element from this stack, then we can delete from top end to the bottom. One condition here, whenever we add an element into the stack or whenever we delete an element from the stack, only the top end is performing. Only at one end we can operate this push operation and pop operation. So during the process of push operation, top gets incremented. During the process of push operation, top gets incremented, and in the process of pop operation, whenever you delete an element or whenever you retrieve an element from the stack, top gets decremented. Let us see some sample algorithm of this. It is a user-defined struct. Initially, create max stack. Suppose the size can be given, whatever the number of elements you want to store. So that is called max stack size. And stack structure consisting key, element, and element is a structure variable. So element stack, max top size. Initially top is a variable. Whenever there is no elements, initially top is initialized to -1. This is in a create a stack. And another ADD, empty stack. So empty stack is initialized to whenever the top is pointing less than 0. Suppose whenever top is nothing but top equal to -1, that is in a stack is empty. If top equal to 0 means there is a one element in the stack. If top equal to 1 means there are two elements in the stack. So that is the condition, empty stack, boolean, either returns true or false. Then full stack is full. Whenever we are performing the push operation, then we must check this stack full. So some size of the array is peak. There is no place to store any element into the stack. So before this, we need to check the max size. For push operation and algorithm for pop operation, let us see this. So the parameters are at the address of the top and element item is an element type, and here first whenever pushing an element into the stack, check this maximum size. To check this overflow, whether the stack is overflow, there is no place, you cannot insert the element, the stack full algorithm must be called if there is no place in the array. So that is checking this top greater than or equal to max stack, then stack is full. Suppose there is a location is free, then this if condition will not be satisfied, then the else part will be satisfied. So whenever there is a place in the stack, I want to add an element, that's why I call the push algorithm. Now increment the first top and store the element into respect to the top position here. Then another operation. Another operation, pop operation. So pop, the purpose of this pop operation is deleting an element from the stack here or removing an element from the stack. During the push operation, top gets incremented. During the pop operation, top gets decremented. So let us see this algorithm of operation pop. If top equals to -1, suppose there is no elements in the stack, then even we are trying to delete an element from the stack, this condition must be true here. If top equal to -1, then stack is empty. Otherwise, if there are elements in the stack, then top element must be deleted. So top minus minus. So top element must be deleted to the user. So next, another kind of implementation, the previous implementation is using arrays. There's another kind of implementation. First method is array based and second one is list implementation. Linked list method here during tag memory allocation here. So let us see the some sample code algorithm for this push and pop operation. Here, this is the part where the link will be made. So initially we can create a node temporarily, node and allocate the memory here. How much amount of memory you want to store? Suppose for a node we need to create. So memory allocation is made here. Then after this is full. So as we know in the stack push operation we need to check the size max size, and here memory is full here. Using dynamic memory allocation here, unless and until memory is exhausted, this condition will not be satisfied here. Whenever there is no space in the memory, then that particular time this particular condition will be true. In general, otherwise at all a node is created. First, during memory allocation process, when node is created, that node I taken as a temp node here and temp dot icon, whatever node consisting of two locations. One is item and another one next. In the item, I would store then applications of a stack. So where we use this stack? In real time where do we use? And computer science examples where actually we use these stacks. If you classify the real time of example of stack, a pile of books as we have seen, then a plate, a box which are open at one end. These are all examples real time. And coming to the computer science example, first one, program execution process here. Now we are executing a C program or C++ program, any program. Suppose let us structure-oriented programming is the best example for this. Suppose we will write here main program. In this we write subprograms. We can write here outside the main. We can write a subprogram. In that subprogram, suppose you have a subprogram that again that will be written in a subprogram. Suppose in this series of you have, then which subprogram is executed first? So the latest subprogram function 1 in function 1 is called function 2, in function 2 called function 3, in function 3 called function 4. Suppose. So which is executed first? Function 4 is executed first, then after function 3 is executed, then after function 2 is executed, then after function 1 is executed. So this is execution process is similar to the stack process. And again another mathematical model example. So evaluating, suppose a mathematical expression we have here. So evaluating an expression, in this we have example application is an input is given to you. Then I want to convert this, evaluate this for given values of A, expression consisting of A and B and C. Then postfix input is postfix evaluation. I want to convert this into the evaluation of expression. So in this process also I can use this stack. There's so many examples like recursion. Recursion is a collection of the function called the itself. In this function calling same function calling the same function n number of times. So here also same process, a stack concept can be used in the process of recursion. Some examples of recursion. This is an example of towers of Hanai. Towers of Hanai is a problem. There are 3 people are there, and the goal is what here? This is source and this is destination. Here we have 3 poles, and here I arranged the disks, bigger one, next smaller one, next so on, and these 2 I have taken here. The objective of this towers of Hanai is I want to move these disks into this disk using this temporary disk here. So how to do that here? The rules, the conditions are here. Disk may be moved at a time, and disk can be placed either on an empty pole or on top of a larger disk. Always, wherever you place a disk, larger one should be, smaller one should be placed on a larger one. This is the condition of this towers of Hanai. Then, suppose let us here in this we have 3 animals. Now, these 3 animals I want to shift here as it is here. Always the goal condition should be satisfied here. A smaller one should be placed on the larger one. So, what should we do here? So, the intention of this here, I want to shift as it is here using this intermediate level. So, one thing, what I will do here, the smaller one I will place here, and this one I will place here. And next after this one I will place here, and this smaller one I will place here. In this concept I will use the recursion. Yes, smaller one I have taken this on the 3rd disk. Next, second this down I have taken on this. Then this smaller one will get into on this. Always the condition is true. Smaller one is on the larger one. Next, and again that is I shifted to element is shifted to here, and next smaller one will be go to that side. Yes, and the second one will be placed to the first one, and third one will be placed to the third. So in this process I will use the stack. Any queries? Okay, stacks can be useful in so many other data structures also. Not only this, in this recursion, so stacks can be useful. Stack concept can be used in that DFS, depth first search, and increase. Also, I can use the stacks. In like this, we have so many examples to be stacks can be useful to implement. Thank you.